prove that sine x is equal to cos pi over 2 minus x. So now for us to prove this one, we're going to use the right hand side, which we're going to pick. So the right hand side, which is equal to cos pi over 2 minus x. Now we know that for the identity, the compound angle, when you're adding 2 or subtracting 2 angles with cos, it is cos pi over 2 and then cos x. So the sign changes, it becomes plus, and then you go to sine pi over 2 then sine x. Now we know that pi over 2 is 90 degrees and the cosine of 90 degrees is 0. So where there is cos pi over 2, we are going to put 0. So that will be 0, and 0 is multiplying cos x and then plus. We have got sine pi over 2. Now sine 90 degrees is 1. So that will be 1, and that is multiplying sine x. Now 0 times cos x is simply 0. So that is 0 plus 1 times sine x is simply sine x. So this is giving us now sine x, hence proven. So apart from this, let's look at one more. Prove that arc sine x plus arc cosine x is equal to pi over 2. Now, of course, we know that arc means sine inverse. So we are going to say, we're just going to pick one portion. Let's pick the sine part. So we are going to say let just any letter. So maybe let's say y represent sine inverse of x. So we are saying arc sine means sine inverse of x. So that is what we've picked. Now when you have got something like this, it means it was first sine y is equal to x. This is what we know. Of course, another way we can do it is we are going to introduce sine this side, and then we are going to also introduce sine this side. So sine and sine inverse are going to cancel, so we are going to only remain with x, and then this side it will be sine y, which is simply the same thing. Now at this point, we can also say that x is yes. Okay, we can also say that x is equal to sine y. So all I've done is just wrote this first and then the sine y. Now from the previous identity that we are from proving, if we can check out here, we are just from saying sine x is the same as cos pi over 2 minus x. So going to this one, where there is sine x, we can also put cos pi over 2 minus y. This is the identity that you've already proven. So that means now check here, we have got arc sine x. Now we know that arc cosine x. And we know that arc cosine x is the same as cosine inverse of x. Now from just this point which is here, if we introduce cosine inverse on both sides, we introduce cosine inverse this side, and then we also introduce cosine inverse the other side, we see that this and this is going to cancel. We're just going to remain with the cosine inverse x here. So which we can also say, as we are used to saying it, we are going to take the cos inverse to the other side. So that is going to give us now this portion, cosine inverse of x, and what are going to remain with here is only pi over 2 minus y. Now remember we said y is sine inverse of x. So we are going to say cosine inverse of x is equal to pi over 2 minus sine inverse of x. Now at this point, we can take the sine inverse of x over the other side. You see that the sign is going to change, is going to become positive. So that will become now sine inverse of x plus cosine inverse of x being equal to pi over 2. So hence proven.